I'm going to work this solution stoichiometry problem by basically drawing a picture. So if we take a look at the question, first of all, let's figure out our moles. The reaction's already written. Tells me that I have 1 liter of 2 molar barium chloride. So if I just kind of figure that out, I'm going to write it over here, 1 liter times 2 molarity. So I know I'm going to have 2 moles of barium chloride. And then for the silver nitrate, I have 1 liter times 3 molar. So I have 3 moles of silver nitrate. And what it wants to know is what compounds remain in solution and what are their concentrations after we're all done. So to figure this out, we can work through and do a BCA table. So I'm going to do that first, and then I'm going to draw a picture. So I know that I don't have any of the products remaining to start with, And so then I need to decide who my limiting reactant is. And I know that I need to have twice as much silver nitrate as I do barium chloride, which is a 1 to 2. And 3 is not twice as much as 2. So I know that's my limiting reactant. So he is my limiter. So I'm going to write the 3 moles under everybody. And multiply by the ratio. So I'm going to get rid of my limiter's coefficient. Divide by 2. So that's that number there. And then multiply by their own. So 1, 2, 2, and 1. So if we work this out, I know that this answer, so this was my before, this is my change, that 3 times 1/2 is 1.5. This is obviously the same, 3 moles. Same thing here, 3 moles. And 1.5 moles. So my after line is I'm going to take how much I used and subtract it from how much I started with. And so after I'm done, I should have a 1/2 mole of the barium chloride. Should have no moles of silver nitrate. And I will have 3 moles of silver chloride formed and 1.5 moles of barium nitrate formed. The deal is, though, and I'm going to go ahead and just kind of draw a picture, extend my page a little, is that this is the picture of the 0.5 moles of the barium chloride is not correct in that these are ions. Barium chloride is Ba plus 2 and 2 chloride ions. So if we take a look at this and draw a picture, it helps to illustrate what's going on. So I'm going to start off with basically drawing a beaker. And I know that in the first liter of barium chloride, so I know I have 1 liter of the 2 molar barium chloride, that I have 2 moles of barium and 4 moles of chloride floating around. Why 4 moles? Is that for every barium chloride, I have 2 chlorines. And so I know that my barium to chlorine will always be twice as much chlorine than I do barium. So that's in that first liter. This is a liter up to this point. So what I'm going to do is just kind of layer it on top. So then I know I have 1 liter of 3 molar silver nitrate. Well, what is that really? Well, my 1 liter in that is going to contain 3 moles of silver ions and 3 moles of nitrate ions because they're 1 to 1. So that's not a big problem. Didn't have to multiply anything. So now what happens when they react? Well, we saw it there. What do we get? Our solid is silver chloride. I know that when they react, that the only thing that's going to be formed is some silver chloride. Oh, AgCl. Ag is plus 1, Cl is minus 1. So some silver chloride, solid. So I'm going to look at my silver. Who do I have more of? Well, I have 3 moles of Ag and 4 moles of chlorine. So they're going to come together, make my silver chloride that's going to hang out here at the bottom. But I know I'm going to use up all of that. I'm going to subtract 3 moles of silver from here. So I'm going to use up 3 moles of chlorine. It's 1 to 1. So I'm going to have 1 mole of chlorine left over. But I'm going to produce 3 moles of silver chloride solid. at the bottom. So if we recalculate all this, and I make it a little neater, I'm going to turn that back to blue, I have 1 mole of chloride ions remaining. But this is the deal. It's asking me for the concentration of everything that's remaining. So what's remaining in my beaker? Oh, 3 moles of NO3, 2 moles of barium ions, 1 mole of chloride ions, and they're all floating in how much water? This total is 2 liters. So now all I have to do to figure out my concentrations is to divide molarity, or my moles, by liters, because molarity. So 3 moles divided by 2 liters, it's going to be 1.5 molar of nitrate ions. I'm going to have 2 moles divided by 2 liters. So that's going to be 1 molarity of my barium ions. And then I'm going to have 1 mole divided by 2 liters, or 0.5 molar chlorine ions remaining. So that's what we do to figure out what is actually remaining. So the BCA table doesn't tell the story as well as really drawing it out and seeing what ions are left over. Yes, I only have 0.5 moles of the barium chloride to start with, but I still have some barium floating on these sides when I'm looking over here. So I have to kind of take that into account if I look at my BCA table. But if I just look at the drawing, it's easier to figure out the answer. So I know it's kind of a mess, but I'm hoping that's helpful to you.